Is the universe real? Wait, how do you know it's expanding? Am I even real? Okay, pause right there. Let's answer this one question at a time.
How do we know that the universe is expanding?
You may come across images like these.
What even is that?
Cosmological redshift.
Isn't there an easier way to sum this all up?
With our team, let's delve into the deep secrets of cosmological redshift. Morning, afternoon, or evening, everyone. I am Ramya. And I'm Natanya. We are representing the School of Science and Technology. Before we delve into cosmological redshift, we will first explain the Doppler effect.
Imagine looking up at the night sky, seeing countless stars and galaxies. Did you know the light from these distant objects holds clues about our expanding universe? Cosmological redshift, caused by their motion relative to us, reveals how they move away, helping us understand the cosmos' evolution. We can demonstrate the Doppler effect using this experiment. We have this path, a moving object, which is a skateboard, and a sound source, which is a tuning fork. We have an audio analysis software, which is the observer, laid on this point in the path. It will record the frequency of the sound source as it moves along the path, towards and away from the observer. This shows that as the sound source moves closer to the observer, the pitch becomes higher. And when the sound source moves away from the observer, the pitch becomes lower. But why does the pitch change? We can use this pipe cleaner to visualize. When the sound source is moving towards the observer, the sound waves compress, making them shorter and the frequency higher. Conversely, when the sound source moves away from the observer, the sound waves stretch, making them longer and the frequency lower.
Now, we understand the basic concept. Let's bring this back to redshift, which is a type of Doppler effect, but instead of sound waves, is light waves. As light waves stretch, it follows this natural progression. Violet at approximately 400 nm, blue, green, yellow, orange to red at approximately 700 nm. That is the visible portion of the electromagnetic spectrum. Hence, when an object emitting light is moving away from the observer, the light waves stretch, causing the light to shift towards the red end of the spectrum.
But back to our question. How does this show that the universe is expanding?
Because cosmological redshift is observed, astronomers have used telescopes equipped with spectrographs to observe redshifted light coming from distant galaxies.
Here's a visual demo of what's happening. This balloon represents the universe, these black dots represent the galaxies, and the red lines emerging from the dots represent the light that the galaxies emit. Now that we've inflated the balloon, the galaxies have moved farther away, and most importantly, the light waves stretched. And guess what the inflating balloon represents? The expansion of the universe.
Adding on to that, here's an invention we made that demonstrates a relative motion between the light source and the observer. So here we have blue and red paper, which represents points in the electromagnetic spectrum. The red represents redshift and the blue represents blueshift, which is the opposite of redshift. It occurs when an object is moving towards the observer. There is a string attached, which I used a face mask for because it is affordable and easily accessible. I used recycled paper to cut out a star, which serves as a paper galaxy. We can imagine the observer at the end of the blue paper. Now, as I stretch the string, this stimulates the galaxy moving away from the observer. As you can see, it moves to the red paper and displays redshift occurring. We can also move the observer or the paper and play around with the string, seeing where the galaxy ends up and what occurs.
And there you go, the mystery behind how we know if the universe is expanding. These deep secrets of cosmological redshift and the Doppler effect are one of the key components that prove the expansion of the universe. Ah, I see. Wait, but you didn't answer my second question. How do you know if I'm real?
Well, are you?